So, good day everyone. I am Silito Alegria, together with my groupmates Kinchin Edra, Kimber Marudo, CJ Mercado, and Lenny Pabispo. And we are going to present our case study entitled Condition-Based Maintenance of a Power Transformer. In a power transformer, electric energy networks require expensive and crucial power transformers. Distribution, in generation, transmission, and distribution system, uh, transformers play a vital role on first generation station. We have a step-up transformer station going to the transmission line. We have a step-down transformer going to the distribution lines. So finally, from distribution lines, we have also a step-down distribution station transformer going to distribution lines below 44,000 volts. So, power transformers unplanned outages have a greater financial impact, which encourages preventive tests and diagnosis to take advantage of condition prediction to optimize maintenance and promote power system reliability. The use of modern diagnostic methods for power transformers offer a way to improve the routine maintenance schedule.
Next is the main issues or the problems. So utilities are approaching to maximize the availability of HB equipment and at the same time. So minimize maintenance costs since it is crucial to lessen its economic impact of a company. So having enough and regular preventive maintenance of this power transformer, it ensures the reliability of its system since it may be experience some unplanned outages that affects its economic impact to every company utilizing it. So the condition assessment of a single phase 167 MVA, the 400 kV over 220 kV interconnecting transformer on site that was reported for abnormal gassing is covered in this case study. So condition monitoring and diagnostic research center or the CMDRC at Global R&D Center Crompton Graves Limited is involved in conditioning assessment of electrical equipment and for helping utilities to understand and use their assets in a more efficient manner. So the experience of CMDRT is evaluating the status of a single phase, the 167 MVA 400 kV over 220 kV. The interconnecting transformer that was reported for anomalous gassing will discuss in this study. Next.
Analysis of the issues. First step of analysis is to study the historical record and conducting oil tests. First analysis was done through dissolved gas analysis or DGA, which enables to get the total gas content of the power transformer. Next is the oil test was also done to get each parameters needed for the analysis. After the tests were done, abnormal gases were detected according to the results of the test, which can be seen from the table. Table 1 shows the dissolved gas analysis wherein the total gas content has a measured values of 2.8, hydrogen has 23.64, oxygen has 54.35, nitrogen has 17,032, methane has 450, carbon monoxide has 126, carbon dioxide has 736, ethylene has 510, ethane has 12, and acetylene has 0.11. For the result of oil parameters, the oil temperature has a measured value of 25.5 degrees Celsius. The breakdown voltage has 40. Neutralization value has 0.0089. The tan delta at 90 degrees Celsius has 0.00025. The resistivity at 90 degrees Celsius has 172.5 times 1012. The interfacial tension has a measured value of 38.33. The moisture content has 9.2. Flash point has 158 and the Furan has 1.
Prescriptions of required offline and online tests. So the online and offline tests recommended and conducted on the transformer as follows. So the first one is the acoustic emission based on the PD test for the partial discharge detection and location. So as you can see in this figure 1, it shows the PD signals obtained at the bottom area of the OLTC side. Then for the figure 2, it shows the actual location of the PD where shows in figure 1. As you can see in this last figure, it shows the actual location of the PD for the figure 3. So the next one is
Next is the thermovision survey to find the hotspot regions. So for this one, all objects with temperature greater than absolute zero or 0 degree Kelvins emit infrared radiation, which can be measured on the electromagnetic spectrums and infrared spectral band. And also, thermography, are also known as thermal imaging, is a technique for measuring and viewing this energy. And the other one is the sweep frequency response analysis, or the SFRA test to assess the mechanical integrity of the core winding. So here we have the SFRA test is a response analysis test is performed offline to determine how the impedance of the test specimen behaves over a specified frequency range. And it's also used to determine the physical condition of the transformer's active elements. And also, it aids in locating the source of the problem with the transformer.
So as per the analysis of the problems in this study, so the analysis of results and recommendations were also done. First, the interpretation of oil results. So as per the IEC 60599 ratio method of dissolved gas analysis, it indicates thermal fault of high temperature ranges of greater than 700 degrees Celsius. Second, all oil parameters are satisfactory. For one level indicates normal aging of cellulose insulation. Second interpretation, the acoustic emission results. First is the PD signal obtained on lower left side OLTC side of the transformer seems like corona generating from arrow-headed sharp PD signals on high voltage side top indicates signals generated have propagated through the oil. Third interpretation is from the thermography. So hotspot temperature differs from up 51.6 degrees Celsius below the curved area on OLTC site indicates internal RC and needs to be monitored. Fourth one interpretation is from the sweep frequency response analysis. So the comparison of high voltage signature with the reference signature indicates the core and winding are mechanically stiff. The recommendations, based on all the interpretations, it is very clear that there are two suspected sensitive points of the transformer. So, lower part on OLTC side and the upper part on the high voltage side. So, on the lower part on OLTC side represents the region of earthing link between the frame and tank. The PD and hotspot obtained at this location indicate the possibility of damage of earthing. That's why they must have a preventive maintenance on the transformer. So the upper part on the high represents the yoke portion. So PD obtained at this location indicates possibility of overheating of core. So from the analysis in this case study, different aspects must need to be considered in order to have a good maintenance of it, from preventive to or future maintenance that will be performed with the equipment.